Welcome back to the Savage Sullivan Math website. Today we're going to look at something kind of cool. We've already posted a video about special cases of systems, but when we graphed them and what they looked like. Today we're going to take a look at special cases, but when we solve them by substitution, how we can tell it's a special case. So here's an example of a system, y equals 2x minus 4, and 6x minus 3y equals 12. So what's nice about solving this by substitution is there's already a variable that's isolated. So I know that I'm going to take this 2x minus 4 and I'm going to substitute it in for the y down here. When I do that, I'm going to have 6x minus 3, remember that 3 stays, it does not go away, times 2x minus 4, again substituting this piece in for y, equals 12. And then we have a nice linear equation that we can solve. So 6x, when we distribute the negative 3 in, we get negative 6x. Negative 3 times negative 4 is a positive 12. And already you should see something kind of funny start happening. When I combine like terms here, I'm going to end up with 6x equals 6x. Minus 6x. So we're going to get 12 equals 12, which should look familiar. What do we know about an equation that has the same thing on either side of the equal sign? We know that it means it has infinite solutions. But here, we know this system must have infinite solutions, which means these two lines will lie directly on top of each other. So what we'll write is infinitely many solutions.
All right, this is the second special case that we're going to solve using substitution. Unlike the one that Mrs. Savage just did, this system of equations does not have a variable that has already been solved for. So we need to solve for a variable. If I look at these, the variable that seems to be easiest to solve for is this y, because its coefficient is an assumed negative 1. So I'm going to solve this bottom equation for y. I'm going to do that by first subtracting the 2x from both sides, and I'm left with a negative y is equal to a negative 2x plus 4. Now it's great that I know what negative y is equal to, but I need to know what y is equal to. So I need to divide everything by a negative 1. So I'm left with y is equal to 2x minus 4. Now that came from the bottom equation. So I know from the bottom equation that y is equivalent to 2x minus 4. So I need to plug that into the top equation where y is. So when I rewrite the top equation, instead of writing a y, I'm going to write its equivalent expression. So for the top equation, I'm going to write 6x minus 3 times my y value now of 2x minus 4 is equal to 3. When I go ahead and start solving this equation for x, I know the first thing I need to do is distribute this negative 3 throughout the parentheses. So I have 6x, and negative 3 times 2x is a negative 6x. Negative 3 times a negative 4 is a positive 12, is equal to 3. 6x minus 6x, when I combine like terms, is 0. So they cancel each other out. So I'm just left with 12 is equal to 3. Oh no, 12 never equals 3. So I guess that means there's no ordered pair that we could pick anywhere on this line that would work for any of the equations. So this system of equations would have no solution. If you found this video helpful, please like and subscribe.